Hello, and welcome back to Learning with Lee. In the previous episode, we discussed the various parts of a program such as the comments, preprocessor directives, and main function. In this episode, we're going to delve deeper into one of those subjects, variables. Similar to how in the last episode we broke down this program into its component parts, in this episode we'll be breaking down this variable and others into its component parts. The first part of a variable we're going to be talking about is its type. This is some of what I had discussed in the previous episode in terms of how I introduced ints, floats, doubles, and strings. Those are all different types of variables. And what a type does is it tells the computer, okay, this variable k can store a certain type of information, as well as that type of information is going to require a certain amount of memory specific to that type. And beyond that, it also tells the computer what operations can be performed on that set of data. For example, this string k can take in what is known as an array of characters, aka what's between these question marks here. And that's really all it can take in. If I try to do something like give it 5, such as pretending as though it were an int, and then I build it, it's going to give me this error down here saying that it cannot convert from an int to a string. But if I do this, builds fine. Beyond strings, there are the types that we covered in the previous episode, as well as a few others, and these, with the exception of strings, are known as primitive data types. And the difference between a primitive data type and something like a string is that a string has a complex definition, because you can have a string that's thank you can have a string that just happens to be you. It happens to have a ability to change its size and how much memory it has there. It happens to have certain operations that are built into that data type itself. So if I did, not to get too far ahead, but k dot, and then there's all these different operations that I can perform on the string, such as I can search for a particular character within a string. However, the other primitive data types, such as an integer, if I do this and then I do I dot, it's not going to come up with anything and just going to say, what are you trying to do? That's an error. So let's go over what the different primitive data types are. I already covered several of these in the previous episode, but for now, let's focus on the ones I didn't. A short, similar to an integer, must be a whole number. The main difference between int and integer is that a short has half the amount of memory that an integer does. And then a long, as you might be able to guess, has twice the amount of memory that an integer does. Floats and doubles we already covered in the previous episode. Just as a reminder, doubles have twice the amount of memory as a float does. A character, which we didn't cover, basically represents, you know how I refer to this as a character array? A character is just a single character, such as T or H, and nothing more than that. Now let's get into the next portion of what a variable consists of, and that is its name. And every variable needs to have a name, and the reason for that is so that I can reference it later on. Because otherwise, if I just say string, don't really give anything to reference it by, if a programming language were actually willing to let you do this, it might allow you to assign that to a certain spot in memory. But you need a way to refer to that spot in memory so that you can use it in the future. And that is the purpose of a name, is that it lets you go, okay, the spot of memory that is the size of a short can be used for things that a short can. We're going to refer to this particular spot in memory as an S. And anytime the S shows up within this scope, it's going to go to that same spot in memory and use whatever data is stored there. And that data gets stored via this equal operation, or assignment operation. So each of these is a variable name. Now, there happen to be some general conventions with regards to how variable names are done. The first thing is that they're what are known as reserved words. So I can't just go short, because, as you see here, it does this to signify that short is a type. And a reserved word is something that a programming language sets aside and says, this can only be used for a single purpose. And that happens to be, in this case, defining the type short, what that memory means, etc. And if people were just to start willy-nilly going around using these ones for variable names also, it would be tremendously confusing, hard to read, and even harder for your computer to turn into a version that the CPU can understand. I'm not going to go over all the reserved words in this episode, but a good rule of thumb is that in case what you are going to be naming a variable is already something that's used in the programming language you're using, or in one of the libraries you're using, it just is a good idea to not do that. Because even if it won't complain about you using that one, and for some of them it won't, for some of them it will, it still will end up being extremely confusing and obfuscate your code for anyone who tries to read and understand it. So, for the sake of code clarity, it's good to not name your variables after something that already exists. For how you can name your variables, though, the first thing to understand is that there's a limited number of characters that you can actually use for naming a variable. So I can't just go this or this to start off a variable name, because each of those actually has meaning within the programming language, and it makes it very difficult for your compiler to parse that statement right there. So the different things you can use for naming a variable. You can use underscores, you can use capital letters, you can use lowercase letters, and you can use numbers. However, you cannot put numbers at the very beginning of your variable name. You can put an underscore at the beginning and then a number, but numbers cannot be at the very beginning. To keep variable names clear, concise, and consistent throughout your program, the development community has come up with a few general conventions and guidelines for how people should name their variables. The first one we're going to go over is what is known as camel case. And that's because, let's say that I had something that was number of students. In this case here, you see that with each subsequent word, I capitalize the first letter, but not the first one in this variable itself. So, of gets capital O, students gets capital S. Sort of like the humps on the back of a camel. And what this does is it makes variables easier to read, as well as it prevents people from having to decide whether they want theirs like, okay, am I going to do mine this way? Am I going to do this? It just makes variable names much cleaner, much clearer for reading it. Another convention that developers came up with a long time ago, but has somewhat waned in terms of its popularity and common usage, is what's known as Hungarian notation. And Hungarian notation allows you to basically go, I want to be able to see what the type of this variable is whenever I see this variable name. So if I'm looking at a variable name 1,000 lines after it's been declared in some file, I don't want to have to scroll all the way back up to know exactly what I can do with it. So the general goal would be like, okay, for number of students, I would go S number of students to signify as a short. While this is useful in some languages and in some programming styles, most modern IDEs have largely eliminated the need for Hungarian notation. And that's because when I hover over something like L or... that's the first one, but let's say I hover over K. K ends up showing string K equals thank you. So it tells me what type it is, does all that in case I were to replace this, say, with S number of students. It tells me that it happens to be a short, which means that having this S here is completely redundant and doesn't necessarily help much with the clarity of your program overall. It really is the sort of thing of, if it's more comfortable for you to do it, in case your company that you work for has that as part of their coding guidelines. Follow the coding guidelines and use Hungarian notation, but otherwise it's really a matter of whatever you're most comfortable with there. Now let's get into how you actually name your variables, because as you might notice in here, we have int for integer, we have char for character, and that tends to imply that developers for a long time ended up abbreviating things, and that's because of one major goal, and that is to reduce the size of this file here. Now, mind you, this doesn't impact the size of the program after it's been converted into something your CPU can understand. However, when memory was a bit more tight, limiting the size of the human readable file was still very important. So every single character actually mattered because that impacted how much memory you were using. In the modern era, though, the fact of the matter is that a plain text file like this is is tremendously small compared to the files that we're used to dealing with in terms of images, in terms of movies, etc. There's no reason to abbreviate things unless you feel that it's clearer or easy enough to understand, especially with modern IDEs, because as you might have noticed, when I began typing this out, I was able to bring up this, and the way in which I did that in Eclipse is by pressing Control, then the space bar. Basically, that acts as an autocomplete. The same thing exists in Visual Studio and in most modern IDEs. And that allows you to just go, okay, I want that. So the length of this isn't going to slow you down any as a developer. Because that was the other reason, was to also avoid having to increase development time by that, but really it was about memory usage. For this, I could say number of students, I could say num students if I wanted to also. Both of those are relatively clear, relatively easy to understand. If I had just gone with something like S and said, yep, S stands for students, or maybe ST so as that it's a bit unique in here, that's really confusing if you have to come back a couple months down the line and debug a program with a bunch of variable names like this. Really, the only times in which you should use short variable names are in case you're doing some well-known algorithm or operation in which it makes sense to have that, such as if I'm going to do the Pythagorean theorem of a squared plus b squared equals c squared. That makes perfect sense to just use a, b, and c for, provided that you name whatever function that you're doing for that something that implies that you're doing the Pythagorean theorem and getting out the hypotenuse. That's a perfectly fine case, and there's some times in which it can be a bit hard to come up with additional names, but the goal is to get unique and understandable names, so as that when you come back, or when somebody else reads your code, it's easy to understand. With that, I'm going to thank you all for watching, and hope you all have a wonderful day. Thank you. I'll see you guys next time.